person is standing on weighing machine, and the weighing machine is placed on the floor of an elevator. The elevator starts going up with some acceleration, moves with uniform velocity for a while, and finally decelerates to stop. The maximum and minimum weight recorded are 72 kg and 60 kg, assuming that the magnitude of acceleration and deceleration are same. True weight of person and magnitude of acceleration. Okay, so what is this question about? First we will make the diagram. So if we have this as elevator, inside the elevator we have a weighing machine, okay, and this weighing machine is there and a person is standing on it, and this whole elevator is going up. Elevator starts going up with some acceleration. So initially there is an acceleration, moves with uniform velocity for a while, and finally decelerates. So in first case, there are three cases. In first case, there is upward acceleration. Okay, so while accelerating upward, while accelerating upward, while accelerating up. So what are the different forces that will act? So there will be its weight. So it will be, I am writing here, that will be its weight mg. Then there will be normal from the weighing machine surface. Okay, and then there will be pseudo force. So it is, since it is accelerating, there will be pseudo force ma0. Okay, so these three things will be there, and the person is not moving inside the lift. So all these three forces are balanced, and the weight recorded by this machine is equal to normal force. That we have already discussed, that the weight shown by any weighing machine is what? That is the normal reaction provided by the weighing machine to the object which is kept on it, or to the person who is standing on it. So normal reaction is the thing which decides how much is the weighing machine going to show. So in this case, we can see the n is coming how much? ma0 plus mg. And since it is written, it is accelerating uniformly, with some acceleration. Okay, these things are given, and magnitude of, assume the magnitude of acceleration and deceleration are same. Okay, so these things are given. So we can assume that constant acceleration we can write like this. So this is the while going up, and second we can write while going while accelerating downward or while decelerating upward. While decelerating. While decelerating up. Decelerating up is equivalent to accelerating down. So pseudo force direction will change. So normal is up, mg is down, and pseudo force is acting up. Why pseudo force is acting up? Because the lift is decelerating upward, decelerating in upward direction or accelerating in downward direction. So acceleration is downward, so pseudo force will be just opposite to that. Okay, so here we can write n plus ma0 equal to mg, or n equal to mg minus ma0. So we can write like this. Then it says that the maximum and minimum weights recorded are 72 kg. So the maximum, in which case it will be maximum, you can see we have a plus sign here, so it will be maximum. So here it is maximum, and we can have minus sign here, so it will be minimum value. Okay, and there is another value when it is moving with constant velocity. At that time there will be no pseudo force, so in that case the normal will be just mg. So this is n max and this is n minimum. And what is the value of n max? That is given 72 kg. So 72 kg means you have to convert it into Newton. 72 kg is a mass, it is not weight. So 72 kg means how much? 72 kg into g, and that is ma0 plus mg. So this is one equation, and here we can write 60 kg into g equal to mg minus ma0. So these are the two equations. So first we have to find what is its true weight. So its true mass we need to find actually. So for that what we can do is g is known. So first we can find we can find A naught. First, it is easier to find A naught. So what we will do is, suppose this is equation 1 and this is 2. So for solving this 2, we can divide these two equations. So if we divide equation 1 with equation 2, what we are going to get? If you divide it, you will have G cancelled, 72 by 60, and M cancelled. You will have A naught plus G, and in denominator you will have G minus A naught. And if you cross multiply it, it will be 72 G minus 72 A naught, and this side it will be 60 A naught plus 60 G. So how much is this? A naught will be equal to, if you solve it, it will be equal to 60 plus 72, and other side it will be 72 minus 60 G. Okay, so A naught will be how much? 12 by, and it is 132 into G. So 12 by 132, how much is this? This is 11 times. 11 times. So G by 11. So A naught is G by 11, and G was how much? 9.9. The G was given. That is given 9.9. You can see the value of G is 9.9 given here. 9.9. If you put 9.9 here and then 11, so we are getting how much? So it will be 0.9. 0.9 meter per second. So this much is the acceleration. Now what will be its true weight? So true weight is m. So we can take any of the acceleration equation. Suppose we take this equation. So 60 into G equal to m G minus A naught. So m will be equal to 60 into G divided by G minus A naught. So how much is that? That will be 60 into 9.9 divided by 9.9 minus 0.9. So this is how much? 60 into 9.9 divided by 9 only. So that is 10, 11. So how much? This is cancelled. So this will be 66. So M is, we are getting 66 kg. So the true weight of the person is 66 kg. But when the lift is accelerating upward, he is recording his weight 72. His apparent weight increases. And when decelerating upward or accelerating downward, in that case, his apparent weight is 60 kg. So his weight is decreasing. Okay. So in this way, we apply the pseudo force.